In this video, we are going to explore Kleiber's law, which is essentially a log-log regression. Then, we will apply Kleiber's law to estimate the daily sheep consumption of a dragon. There are several learning goals for this video. First, we will understand how to represent a data set with very large and small numbers on a log scale. Second, we will learn basic data visualization techniques. Third, we will explore regression and log-log regression. We are going to use several Python libraries, including Pandas, Matplotlib, Seaborn, Plotly, scikit-learn, and stats models. First, let's take a look at the dragon's eating problem.
We already made a promise to all the Crown lands that a tithing of livestock would be necessary to sustain the dragons for their increased activity and, pray not, eventual fighting.
Right. After further thought, I have decided that I cannot restore your sheep. If war were to break out, my dragons will require feed. Bring the next.
Second, let's review Kleiber's law to address the dragon's eating problem. The law is named after Max Kleiber for his biological work in the early 1930s. It states that for the vast majority of animals, an animal's metabolic rate scales to the 3/4 power of the animal's mass. On my GitHub website, you can download a dataset that contains information on animal weight and daily energy needs, along with the Python notebook. We will go through the data analysis shortly. Notice that in the dataset, there are tiny animals, such as rats and bats, who weigh under 50 grams, and heavyweight animals, such as elephants and blue whales. How can we clearly visualize these polarized cases on a graph? In a linear scale, each unit of increase is equal across the entire range of values. For example, each unit of increase, 2, 4, 6, etc., is the same distance apart. This type of scale is useful for uniform data. In a logarithmic scale, each unit of increase represents a multiplicative factor. This means that the distance between 2 and 4 is larger than the distance between 4 and 6. A log scale is useful for data that spans several orders of magnitude or for data that grows exponentially. Therefore, using the logarithmic scale can help visualize both small and large values clearly. For instance, tiny animals and massive animals can be represented on the same graph without losing detail. To create a log scale, we can either use the built-in log scale option or explicitly define the log transformation as a new measure. Either way, we can achieve the same data visualization for both small and large animals. Next, we will convert Kleiber's law into a log-log regression model. There are two Python packages we can use to run regression analysis. The first is the scikit-learn package, and the second is the stats models package. The second option offers more statistical outputs, such as confidence intervals. We can visualize the regression output and compare the fitted value line in the 95% confidence interval with the actual data points. Notice that the regression model underestimates the daily feed for blue whales. Finally, we apply Kleiber's law to estimate the number of sheep a dragon needs to eat daily. The weight of a dragon can easily be larger than that of a blue whale. For instance, Drogon is estimated to be the size of a Boeing 787 airplane and can weigh over 250 tons. Vhagar is a much larger dragon, 3 times the size of Drogon and likely weighing 10 times more. By applying the log-log regression estimate of Kleiber's law to the approximate weights of dragons, we can calculate how many sheep a dragon can eat. A range between 10 and 50 sheep daily, depending on the dragon's size, seems to be a reasonable estimate. If you want to keep a dragon as a pet, it will cost thousands to tens of thousands of dollars daily to feed it, and you'd better buy liability insurance.